Hi there. If, like me, you like using past papers to do your revision, then you may, I'm afraid, have to see this introduction quite a few times. But the whole point of past papers is it helps you hone the kinds of questions you're going to have in an exam. So it puts the maths in the context that you're going to need to do it. A lot of students I've taught over the years have known what maths to do, but come unstuck in the exams because they're not quite sure what maths they're being asked for. So throughout these videos, what I want you to do is pause it, have a really good go at the question, and then mark it going through looking at my explanation in detail. If you've got it totally right, then just give it a tick and you can move on to the next bit, and that's great. You may want to have a look around the internet and search out for the exact copy so you can print it off and go from there. But there's very few questions that actually need you to have the scaled drawing or whatever's there. Most of it you don't need to, and you can get the top grade, whether you're doing the higher paper or the foundation paper, just by honing all the skills that don't need that. Hopefully we know by now that this is actually called the November paper because no one sat it in the summer, so they just rolled it over. In order to get a grade 5 on this paper you need 55, but as far as the whole thing is concerned, if you take papers 1, 2 and 3 and if you times that by 3 you get 165 on all 3 papers all added together. But on this paper you want 55, which is a bit more than 60%. 45 for a grade 4, just over half. You can make sure you don't get a U as long as you get at least 9 marks on the paper, but obviously we want a bit more than that. Now just make sure, once again, you've got yourselves a calculator. You do want something appropriate. Don't go using your mobile phone unless that's all you've got with you. You can't use it in the paper, and these buttons on here make life a lot easier than any mobile phone layout I've ever seen. This is the sort of classic calculator that's easy to get hold of in many supermarkets and things for normally just under £10 or online. Anyway, time to crack on. Here's the first 3 questions for you to have a go with. 100 centimetres equals 1 metre, so you just need to divide by 3 to give you 3 metres. 1/3 of 24, again you're dividing by 3 because a third of something is it divided by 3, so you've got your 24 and we just want 1/3 of it. So 8 plus 8 plus 8 makes 24 because 3 times 8 equals 24, so it is 8. 40% as a fraction. Well, remember the percentage symbol means divide by 100, and you can turn it into a fraction by doing that. Now they won't actually give you a mark for 40 over 100, although they should do because it doesn't say in its simplest form, but that's what you should do really. Haven't actually seen the mark scheme, so who knows, you might get away with 40 over 100, but you shouldn't do. We should then be, I think there should be 2 marks for this question, 1 mark for that, and then 20 is the biggest number that goes into both of them. 5 20s in 100, 2 20s in 40, so 2/5 should be your final answer. And although it says you must write down your working for all of these, for any of these, just the answer on its own will do. Questions 4 and 5. So 2.5 with a little 2 means 2.5 squared, so you're looking at 2.5 times 2.5, but remember you've got your calculator, you don't need to do 2.5 times 2.5 without it, so I'm going to put 2.5 in there, and then that little squared button will do it. You can see it's exactly the same as what's there. Hit equals, and it says 25 over 4. Now if you write that down you would get the marks, but it's more normal to go for the decimals, which you can do by toggling through with this S to D button. So that is 6.25, and that means third to decimal, by the way. Right, writing the following numbers in order of size. Well, the more negative something is, the smaller it is. So it's -6 is the smallest. Start with the smallest number. There's only one mark, so if you start with the biggest and get it in the right order, but going the other way, you will not get a mark. So we've got that. Now normally I also like to cross them out as I go to make sure I don't make a mistake. Then it's 0, then it's 1, 2 and 7. Question 6 is 2 1-mark questions. Have a little look at the bar chart. So for how many of these, so it's car production over 8 years. For how many of these years was car production more than 1.4 million? Well, 1.4 million is there, so it's 1, 2, 3, 4, 5. In which 2 years was the car production the same? And that's there, isn't it? So that is years 5 and 6. Question 7, another fractions question. So all you need to do is count how many squares you've got altogether for the original denominator. So it's 4 by 4, which adds up to 16 squares. The number of them that are shaded, well, there's just 4 that aren't, so that must be 12 that are shaded. That'll get you 1 mark. Now what number goes into 12 and 16? Well, you could halve them both and halve it again, or if you spotted that 4 goes into 12 3 times and 4 4s make 16, then that gives you 3/4. So that's 2 marks, that's 1 mark. Question 8, give this one a go. Right, so Karen buys 200 tiles, they're sold in boxes, there are 25 tiles in each box. So 200 divided by 25, do that with your calculator, should tell you 8. So that means we've got 8 boxes and each costs 9.75, so then you need to do that times 9.75. So 8 times 9.75 equals 78. So that must be £78. Nice little 3-mark question there, but just think through what it is that it's asking you. Question 9, the third part's also 1 mark, so have a go at this. The top 2, hint to you, put it in the calculator just as it looks like and press equals. For C you need a bit of knowledge. So if you do 300, oh, it's a fraction, so hit the fraction button, 300 over 2 times 5, that'll do 300 divided by 10 for you, which is 30. You don't even need to do the maths, it's just making it look like what's there. Let's do the same thing again here. You could do it by working out what each bracket is and then timesing the 2 things together, or you can just do 6, take 2.5, close brackets, open brackets, 8 add 4, close brackets, which we should all know is 12, equals, and it's done it for you as 42. Now, reciprocal means turning a fraction upside down. So the reciprocal of 3/4 would be 4/3. Any whole number is the same as saying 20 over 1. So that's what we need to turn upside down. It means sort of like the opposite. The opposite of timesing something by 20 would be finding 1/20th of it. That's where it comes from. So 1/20th. Now this question will be easier for you to do if you have managed to print off the paper. If not, just follow it through now. So the graph is showing information about the time in minutes a liquid has been cooling. So it's starting at 100 degrees, so it must have just been, maybe it's someone's just made a cup of tea or something and it's got at 100, and then it gradually cools over time. What is the temperature of the liquid at time 2 minutes? So I do recommend using a ruler here just to really doubly make sure at 2 minutes, if we go up, we hit the curve, and then we go across and read there that it says 80. So it's 80 degrees. The next question is Pam recorded the time when the liquid had a temperature of 50 degrees. write down this time. So we're just doing the same thing in the other direction. 50 degrees, go across until we hit the curve, and that has happened at exactly 8. So it's 8 minutes. Then there's one more question on this. Pam says that the temperature of the liquid drops more in the first 3 minutes of cooling than it does between the time 9 minutes and 12 minutes. Is she correct? Give a reason for your answer. So we need to work out how much cooling it's done in the first 3, then there. And I think she's going to be right, because in fact we can look at it. In the first 3 minutes, the curve is steeper, isn't it? In the last 3 minutes, it's less steep. So that is a good enough reason. You could say, so it's yes, but you won't get a mark for yes. You have to have yes, and then you have to have a reason. So you could say, in the first 3 minutes, it drops, well, from 100 degrees to 73. So 100 to 73, 27 degrees. But from 9 to 12 mins only, and it goes here from 47 only about 7 degrees. Or you could write something to say that the curve is getting less. Over time, the rate of cooling is decreasing. You could write something about that. An angles question now. Got to find y. There's 3 marks for it. You're going to need to show your working. It doesn't ask for the exact reasons of things like angles on a straight line add up to 180 degrees, but it wouldn't hurt you to put that in. Right, so a quadrilateral sums to 360 degrees. So we need to add 130, 95 and 65, which we can do with our calculator to get 290, and then 360, take 290. Don't take any chances, because you can get in a flap in an exam and make a silly mistake. So actually put it in there. Double check that you've got it on the calculator what you had there. So that is 70 degrees. I now know that that is 70 degrees. To get the final thing, remember what I said about angles on a straight line? Sum to 180 degrees. You get a mark for saying that, and then you get a final mark for saying 180 take 70 is 110 degrees. So y equals 110 degrees. Right, now I recommend getting into sequences if you don't. Nth term, a lot of people don't like it, but actually they're easier to revise for than others. What we're looking at first of all, the next 2 terms of the sequence, well that is minus 5, take 5, take 5, take 5. We're taking 5 each time, so if you take 5 from 25 you get 20, 5 from 20 you get 15. A term of this sequence is minus 5. Which term? Right, so there's a couple of ways of doing this. You could just continue going on, 20, 15, 10, 5, 0 and negative 5, and then count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and that's the 11th. Or if you're confident at working out what the nth term is, because it's going down in 5s, that means it's minus 5 times, so it's minus 5n. What do we add to minus 5 to get 45? You'd have to add 50. So we could work this out as saying, how do we get to minus 5 with that? Take 50 from both sides, and you'd get minus 55. divide both sides by negative 11, and you would get n equals minus 5, so that must be 11. You could do it that way, but maybe just drawing it out when it's not too many might be easier. The nth term of a different sequence is given by the expression 4n plus 3. Find the nth term. So I like to use function machines here. To get 4n, I would have to times by 4, and then to get 4n plus 3, I would have to add 3. So that's how this sequence works. And it would start with 1 going through and so on. For the 9th term, you would put 9 through. 9 times 4 is 36. 36 plus 3 is 39. Question 13 then, working out the perimeter of the shape. Now there's a quick cheat way of doing these L-shaped ones. If you imagine making a box all the way round, can you see that that would be the same length as that, and that would be the same length as that? Actually, going in and there is the same distance as going all the way round that. So the rectangle would be 10 plus 7 is 17, would get you halfway round, times it by 2 gets you to 34. Now you may have done it by saying that's 5, 5 plus 2 makes 7, that's 4, 4 plus 6 makes the 10 across there, and then added all of those numbers up. You should still have got 34. Question 14, algebra, simplifying and solving equations. Again, really worth revising this stuff. It comes up very similar every time. So we need to know how many x's we've got and how many y's, because x is a different number to y, so we don't know what they are. But we can say that I've got 3x and 2x, and if you add them together you'll get 5 of whatever that number is. And if you take 4 of a number away from 5 of it, you'll just have 1 of it left. So 5x minus y. If you actually wrote minus 1y, you still get the marks. If you get either of those but not the other one, you get 1 out of 2. Right, solving an equation, 5p plus 7 equals 22. So this means the number is multiplied by 5 and then has 7 added. First thing to do is reverse the adding of 7. I take 7 away from both sides, would give me 5p on that side. 22 take 7, use your calculator just to check, it is 15. And then 5p means 5 times p, so we reverse timesing by 5 by dividing, and 15 divided by 5 is 3, so p equals 3. You can check you've got the right answer, because 5 times 3 is 15, 15 plus 7 makes 22. Question 15, costs of 2 different types of battery. So you just need to go through and work it all out. Which shop would you buy from? So there's going to be 1 mark at the end for saying shop A or shop B. But just if you say shop A or shop B and do nothing that's correct, you won't get any marks. Anyway, Harry needs to buy at least 30 batteries. So we need to work out how much it would cost him in each one. He assumes he has to buy them in whole packs. Now, for shop A, 30 batteries divided by 4, that's going to be 7.5 packs, but he can't buy 7.5 packs. He's going to need to buy 8. So 8 times £1.60. Put that into your calculator and you should get, I've got 12.8, which is £12.80. And then we go for shop B, a pack of 6 batteries. Now 30 divided by 6 equals 5 packs exactly. So he needs 5 of his £2.70 packs. Put that in the calculator and you should get 13.5, which is £13.50. Now that's more expensive, so this is cheaper. So we then need to say he should buy from shop A. Now it says Harry's assumption is wrong. He can buy single batteries for 40p each in shop A and for 45p each in shop B, which is more expensive than when they're in a pack on the whole. Does this affect which of these shops Harry should buy the batteries from? Well, that's just making it cheaper in shop A than it would be in shop B, because he could just, so it won't. So no, because shop A is already cheaper and this deal just improves shop A and makes shop B more. Well, you don't really need that last bit, don't know why I wrote that. But anyway, so the important thing is to recognise that in here, this is making it cheaper again to shop from shop A, and we've already chosen shop A. Question 16. Part B is just worth 1 mark, by the way. Probability. Right, so write down the probability that Isabella will take a blue card. There are 5 plus 2 plus 4, which is 11 cards altogether. There are 5 blue ones, so the probability, just do it as a fraction, 5 out of 11 is the easiest way to do it. You could do it as a percentage by doing 5 divided by 11, 11, and pressing it to that, and it would be 45.45 recurring percent, or you could do it as a decimal, but there's no point. Fractions are your friends. Ken is going to throw a biased dice once. The probability that the dice will land on 6 is 0.3. What's the probability it won't land on 6? Well, there's only 2 things that can happen there, and all probability always adds up to 1. So all you need to do is 1 take 0.3, which is 0.7. Okay, we've reached halfway, so this will be the last question for this video. The rest of it will all be on the next video. Draw accurately an isosceles triangle with sides of length 8 centimeters, 6 centimeters, and 6 centimeters. So you can do this even if you haven't got this line drawn for you already. All you need to do is get a ruler and draw 8 centimeters for your first line. We can check that spot on there. The other thing you're going to need is a pair of compasses, and they are going to want you to leave your construction lines in, although it doesn't say so. It always used to say so. I don't know why they've stopped saying, but they have, because you're getting marks for showing you can do this. So what we need is, we need a point which is both 6 centimeters from this end of the line and this one, so that we get 2 6 centimeter lines. All you got to do, get your ruler, open up your compass to 6 exactly, and you want to make sure, by the way, that it's nice and stiff, so you might need to get a screwdriver on your compass just to keep it like that so it doesn't lose position. Now I put my point in that end of the line. Now the key to drawing well is to make sure that the weight you put on is all on here. Just the weight of the pencil on the paper, I'm not putting any weight on the pencil, is enough to make a line that I can see. Now I trot along to the other end of the line and put the point in there and do another arc. If you want, some people like to do a whole circle, but you just need an arc enough so that they cross. This point here is where we are at the same time 6 centimeters from here and from here. So then you just connect from there to there and there to there, and that'll be 6 centimeters. That'll be 6 centimeters. You can check by getting your ruler, seeing that 6 there and that 6 there. They will allow you to be a millimetre or two out. It's the method that they're really keen on seeing. And that's all for the first side. We've done 40 marks. The 40 slightly trickier marks coming up.